Hello, this is a YouTube project of KAIST MS310 class. We'll explain quantum entanglement through Milky Way experiment. To help us understand the Milky Way experiment, I would like to explain quantum mechanics, EPR paradox, Bell's inequality, CHSH game in order. Until the 19th century, it was mainly classical physics that knowing the present state of matter, such as Newton's law, theory of relativity. However, a phenomenon that cannot be explained by classical physics such as black body radiation, line spectrum, and work function has been discovered. Unlike classical physics, we concluded that energy is not continuous in the micro world, which is called energy is quantized, and became the starting point for quantum mechanics. EPR paradox announced in a paper that Einstein and Podolsky-Rosen had discussed with imperfection in quantum mechanics, which is called EPR paradox after the alphabet. Before we explain the EPR paradox, I will explain the concepts of locality and realism, which are important in classical physics. Locality means that two objects that are far from being able to reach the speed of light cannot affect each other at the same time. The definition of realism says it does not disturb the physical system that has an actual element that responds to a physical quantity if it can be accurately predicted. The EPR accident test resulted in the collapse of the pion with zero angular momentum, resulting in the creation of a pair of electrons and positrons. At this time, electrons and positrons have spin momentum, which is zero in total according to the angular momentum law. If the electron is spin up, the positron has spin down, and the electron is spin down, the positron has spin up momentum. And then, to prevent electrons and positrons from transmitting information to each other before observation, we said the electrons and positrons are kept very far apart. According to quantum mechanics, electrons overlap in many states. Therefore, the intensity measurement is determined and only one value at a time is measurable. But if the x-axis value of the electron and the z-axis of the positron are measured at the same time, the x-axis and z-axis of the electrons and positron can be known at the same time, which is in violation of the uncertainty of Heisenberg. But Einstein explained that from the momentum of collapse, spin is determined, quantum mechanics are incomplete, and there will be hidden variables that we don't know. Until his death, Einstein did not accept that natural phenomena were dominated by probability, leaving the words, God does not play dice with the universe. There was someone interested in this accident experiment. His name is John Stuart Bell, a British scientist. Bell presented an inequality in which practicable experiments and expected values of experiments should be satisfied if there is a hidden variable in the position of defending the EPR. CHSH game is another view on the Bell's inequalities, showing that under the hood our world is not classical. The game is played by Alice and Bob, and proceeds as follows. First, a leaflet generates two independent uniformly chosen random bits, x and y, also called questions, and sends x bit to Alice and y bit to Bob. Second, after receiving the questions, Alice and Bob send their answers back to the leaflet. An answer is 1 bit too, A for Alice and B for Bob. Third, Alice and Bob win if x dot y equals a XOR operation with b. In classical mechanics, winning probability is 75% because there are only 4 choices of A and B. But in quantum mechanics, they have additional degree of freedom, which is before the game starts they share an entangled bipartite state. For example, the biggest state of two entanglement qubits is shown as cat psi AB is equal 1 over root 2, cat A0 tensor product with cat B0 plus cat A1 tensor product with cat B1. The reason why we consider vector of question is Alice and Bob stochastically are determined to be question A or B depending on the angle. So, basic vector of question can be represented as cat B0 theta is equal cosine theta cat 0 plus sine theta cat 1. Also, cat V1 theta is equal sine theta cat 0 minus cosine theta cat 1. Let Alice uses theta A0 on receiving the question 0 and theta A1 on receiving the question 1. Bob uses theta B0 on receiving the question 0 and theta B1 on receiving the question 1. Winning possibility x is 0, y is 0 is equal absolute value of bra A V0 theta A0 tensor product with bra B V0 theta B0 cat psi A B square plus absolute value of bra A V1 theta A0 tensor product with bra B V1 theta B0 cat psi A B square. And then substituting cat B I theta, we can get it is same as absolute value of cosine theta A0 bra A0 plus sine theta A0 bra A1 tensor product with cosine theta B0 bra B0 plus sine theta B0 bra B1 cat psi AB square plus absolute value of sine theta A0 bra A0 minus cosine theta A0 bra A1 tensor product sine theta B0 bra B0 minus cosine theta B0 bra B1 cat psi AB square. And then substituting cat psi AB, we can get it is 1 over 2 multiply absolute value of cosine theta A0 cosine theta B0 plus sine theta A0 sine theta B0 square plus 1 over 2 sine theta A0 sine theta B0 plus cosine theta A0 cosine theta B0 square. Finally, winning possibility is cosine square theta A0 minus theta B0. And next two slides explain winning probability when x is 0, y is 1, and x is 1, y is 0, and x is 1, y is 1. It is similar to before slide, so we will skip quickly. If you want to know process, stop the video. Finally, putting it all together, winning probability is 1 over 4 multiply sum of probability when x and y are 0 or 1. It is 1 over 4 cosine square theta A0 minus theta B0 plus cosine square theta A0 minus theta B1 plus cosine square theta A1 minus theta B0 plus sine square theta A1 minus theta B1. And then, by mathematical method, it is figured out that when theta A0 is 0, theta A1 is pi over 4, theta B0 is pi over 8, theta B1 is minus pi over 8, it have maximum possibility. Then, winning probability equals to 0.85355. This is winning probability in quantum world. In CHSH game, we can make maximum expected value inequality. If expected value s is same or bigger than 2 and is same or smaller than 2 root 2, it satisfies the quantum mechanics. Here, 2 means classical mechanics maximum value and 2 root 2 is quantum mechanics maximum value by mathematical technique. The preceding formula is a simple method of calculating winning probabilities, which is different from the actual expression. However, the range of S we are talking about is the same. It means quantum entanglement exists and not local hidden variable exists. We can prove Einstein is wrong, and God also played dice with the universe. Additionally, we will explain loophole, which is assumption in experiment situation because loophole is shown in all experiments. The definition of loophole is the problems of experimental design or setup that affect the validity of the experimental findings. But in experiment, loophole is used as an assumption and there was no experiment. without the loophole. Loopholes vary widely, but the following three are major loopholes. Locality's loophole means the possibility of one's observations combining any information before the other. It can overcome by sending to the other side of the universe because of theory of relativity. Fair sampling loophole is assuming that the sample of measured photons accurately represents the entire ensemble. Freedom of choice loophole means the possibility that the setting choices are influenced by hidden variables too correlated with the particle properties. Among them, other experiments usually assume fair sampling loophole using quantum random number generator. But using fair sampling loophole have problem which left open the possibility that an unknown cause affected both the setting choices and measurement outcomes as recently as mere microseconds before experimental trial. Likewise, some scientists propose these problems, and to solve these problems, the experiment using locality loophole is introduced today. Cosmic bell test is one of them. We are going to conduct an experiment with an environment called Milky Way with certain assumptions, which is the space-time region from which any such unknown causal influence couldn't have affected both the measurement setting and outcome. Since the light that was influencing the measurement was billions of light years away, any hidden force that could have influenced this measurement of both particles would have needed to happen billions of years ago to somehow influence the way scientists measure these particles here on Earth today. Consequently, it solved the locality loophole problems. This slide introduces experiment implement. It used to replace OEMB, IQOQI, BOKU, which distance is over 1,500 meters. TXEP is located at the rooftop of IQOQI, which sends the photon via free space quantum channel to Alice and Bob. RXEP is measurement station for Alice and Bob, each feature an entangled photon receiving telescope. Polarizing beam splitter means polarization analyzer. RXSP receives stellar photons by Milky Way. Setting reader splits stellar photons to red and blue. CADA control and data acquisition unit. Electro-optical modulator allows fast switching between complementary measurement bases. Finally, SPAD is single photon avalanche diode. As a result of the experiment, it was possible to derive the value of S. First data S is 2.425 and second data S is 2.502, which shows the value denying the Bell theory. In other words, it is seen as a counter-reference to the theory of local hidden variables. These are what we refer to. This is end of our video. Thank you for watching.